Now let's check out this example. Alright, it's saying evaluate the following. On A we have the logarithm to the base of 3 of 27. On B we have the logarithm to the base of 4 of 8. And on C we have the logarithm to base 5 of 0.2. Now remember, in our introductory video we learned how to convert from logarithm form to index form. So that's exactly what we're going to be doing to evaluate these logarithms. Alright, so we're going to start with A. On A we have the logarithm to base 3 of 27. Right, remember our log form is the logarithm to the base of a of n, giving us x, and we can express this in index form where we have our base a being raised to the power of x being equal to the number n. So that's a to the power of x equal to n. That's our index form. Alright, also on a here we'll be saying, we can say let log to the base of 3 of 27 be equal to x. Alright, so that in index form then we'll be saying that the base 3 raised to the logarithm the power x will give us the number 27. So in index form we have 3 to the power of x equal to 27. Now this is now an equation that we can solving for x. And you see, to solve this equation we can express both sides of the equation to have a common base. We know that 27 can be expressed with base 3 because 27 is 3 to the power of 3. Now since it's an equation, since the bases are the same, automatically it means that the powers also will be the same. So therefore we can say that x is equal to 3. So that's our solution. That's our logarithm to the base 3 of 27. It gives us 3. Alright, so let's go on to part B, just doing the same, just like we were doing on part A. On B we have the logarithm to the base of 4 of 8. So we can say let that logarithm be equal to a value x. You can use any unknown, any letter. You can even use y. I'm just using x here, but you can use any letter. So in index form that will be 4 to the power of x. We are saying this base to the power of x gives us the number 8. So that's our index form. And expressing both sides to have the same base, we can use the base 2. So we know that 4 is to the power of 2, and we have an x right there. And 8 is 2 to the power of 3. That's 2 cubed, which therefore means that automatically our powers will be equal. 2x is equal to 3. And if we divide both sides by 2 in order for us to get the value of x, then we'll be getting x being equal to 1.5. That's dividing 2 into 3. So that's our solution on B. The logarithm to the base of 4 of 8 is 1.5. Right, so that's how we handle that one. Lastly, let's check out our part C. On C we have the logarithm to the base of 5 of 0.2. So let's work this one out. Right, let's check out part C. We do the same. Let the logarithm to the base of 5 of 0.2 be equal to an unknown like x. So in index form that will be 5 to the power of x is equal to the number 0.2. Right, and you know 0.2 as a fraction is 1 over 5, which can also be written as 5 raised to the power of -1. Right, so we can therefore say that x is equal to -1, and that is the solution to part C.